In the vast theater of the cosmos, there exists a giant red star that has captured the imagination of astronomers and stargazers for generations. Just above the horizon in the night sky, this brilliant red beacon glows with an intense and mysterious light. It's called Betelgeuse, and it proudly rests on the shoulder of the Orion constellation, one of the most recognizable formations in our sky. But Betelgeuse is no ordinary star. It's one of the most massive and unpredictable stars ever observed by science. Its sheer size, staggering energy, and behavior continue to amaze and mystify experts around the globe. To grasp the scale of this celestial monster, imagine this. If our Sun were suddenly replaced by Betelgeuse, its outer surface would extend far beyond the orbit of Jupiter. The inner planets, Mercury, Venus, Earth, and Mars, would be completely consumed, turned into a swirling inferno of gases and plasma. Our solar system's familiar layout would be unrecognizable. Few stars in the known universe can compare in magnitude. Betelgeuse is classified as a red supergiant, a rare type of star in the final stages of its life. This is a star teetering on the edge of one of the most dramatic events in cosmic history, a supernova. When Betelgeuse does explode, and it could light up the sky in a way no living human has ever seen. Its death would be visible even during the daytime, casting shadows at night and possibly outshining the moon. It wouldn't be just another blip in a telescope or a momentary headline in scientific circles. This would be a once-in-a-lifetime spectacle, a rare cosmic performance that might rewrite what we know about the life and death of stars. In our part of the galaxy, supernovas are exceptionally rare. Witnessing one this close would offer scientists an extraordinary chance to study the phenomena in real time. Betelgeuse already stands out in the sky. Its reddish glow pulses and flickers like a beating cosmic heart. This variability in brightness has captivated observers for centuries. In late 2019 and early 2020, the star's behavior took an especially curious turn. Its brightness dimmed drastically, sparking global excitement and concern. Was this the long-awaited moment of explosion? Could we be days or weeks away from witnessing a stellar death? Telescopes all around the world, on the ground and in orbit, were aimed at Betelgeuse to investigate the mystery. What they found was astonishing. The Great Dimming, as it became known, was not caused by the star collapsing, but likely by a massive cloud of dust that Betelgeuse expelled, temporarily blocking its light. Even so, the event served as a stark reminder of how volatile and powerful this aging star truly is. Its energy and unpredictability are awe-inspiring. The sheer scale of the star defies imagination. Betelgeuse is estimated to be around 764 times the size of our Sun. That number is almost incomprehensible. Its outer layers are so spread out that it's hard to even define its edges. And yet, you can see it with your naked eye, glowing red in the night. The red hue is more than just a color. It tells a story. It means that Betelgeuse is cooler than stars like the Sun. For millions of years, it has generated energy by fusing hydrogen into helium in its core. But that process is nearing its end. The hydrogen fuel is running out. As this happens, gravity starts to take over, pulling the core inward while the outer layers expand. This battle of forces causes the star to balloon outward, forming an enormous, unstable shell. It's like watching a breathing, dying giant take its final breaths. If Betelgeuse were placed at the center of our solar system, its surface would extend past the orbit of Mars. The inner planets would vanish inside a scorching cloud of superheated plasma. It's a staggering image. And yet, what excites scientists the most isn't just its size or heat, but what comes next. The star is approaching the tipping point. Could explode tomorrow, or next year, or even 100,000 years from now. That's the uncertainty that keeps astronomers watching, studying every flicker and shift in its glow. They use powerful tools, from ground-based observatories to space telescopes, to monitor its brightness, temperature, and position every single day. Betelgeuse wasn't always a red giant. Long ago, it was a blue giant, hot, massive, and extremely bright. Over time, it consumed its nuclear fuel, transforming its internal chemistry and cooling down into the red supergiant we see today. During this transformation, Hydrogen in its core was converted into helium through nuclear fusion, releasing energy that powered its glow. When the hydrogen ran low, gravity collapsed the core inward, pushing Betelgeuse into its final evolutionary phase. Its current reddish color signals a cooler surface temperature, though it's still hotter than anything we can truly fathom. One of the most intriguing aspects of Betelgeuse is that it's a variable star. Its brightness isn't constant. It changes over days, weeks, and months. These variations hint at the star's inner turbulence. During the Great Dimming, scientists from NASA, ESA, and major research institutions around the world rallied to study the anomaly. Dr. Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics remarked, "We've never seen anything like this. The star is behaving in ways we never expected." Dr. Miguel Montarges added that their analysis pointed to a giant dust cloud, likely formed when Betelgeuse ejected a large portion of its atmosphere. "We're watching history unfold," he said with excitement and wonder. "When the inevitable explosion happens, the resulting supernova will light up the sky like nothing seen in modern history. Some predict it could rival the brightness of the full moon and remain visible for weeks. It might even cast shadows on Earth at night. But this isn't just about a celestial light show. A supernova unleashes a torrent of energy, neutrinos, gamma rays, and shock waves that travel across the galaxy. These signals carry vital information about the nature of stars, the formation of elements, and the birth of new systems. And the good news? Despite its proximity at 640 light-years away, Betelgeuse is too far to pose any threat to Earth. Instead, it offers a front-row seat to a majestic and ancient cosmic event. Scientists are particularly eager to see what remains after the blast. Betelgeuse could become a neutron star, an object so dense that a single teaspoon would weigh more than Mount Everest. If the collapse is even more extreme, it might transform into a black hole, a region of space where gravity is so powerful that not even light can escape. Observing such an outcome would allow us to study gravitational waves, neutrinos, and high-energy radiation in a whole new way. The debris from the explosion may take on strange, haunting shapes, some resembling bubbles, butterflies, or glowing eyes drifting through the cosmos. For now, Betelgeuse continues to shine from Orion's shoulder, especially prominent during winter nights in the northern hemisphere. When you look up and see that red dot twinkling in the sky, remember, you're looking at a cosmic countdown, a ticking time bomb that has been slowly winding down for millions of years. No one knows when it will go off, but when it does, it will change our view of the universe forever. And we, the people of Earth, will be the lucky witnesses to one of the greatest shows in the galaxy. So keep watching the skies, because one day, perhaps very soon, the night will turn to day, and Betelgeuse will write its final fiery chapter across the heavens.